Hi, my name's Andy Ebbs. I'm a solution consultant at OpenText, and today we're going to have a look at Carbonite Migrate and its full server to ESX workflow. Previously, you may have seen some of my other videos which focused on the standard full server migration workflow. That requires you to have a target machine already created, and then we're going to take a copy of your production server and overwrite that plain target machine before then cutting over into the new environment. That's great if you've not got access to the hypervisor at either end, because we don't need hypervisor access. We're able to go pretty much anything to anything, so physical to physical, or physical to cloud, or cloud back to physical, or any of the different virtual platforms. And in fact, there's quite a few different videos I've uploaded which show that. However, if you have VMware ESX, or to some extent if you have Hyper-V in a similar way, we can use the full server to ESX workflow. And this is designed to simplify the process of migrating lots of machines into an ESX environment. It's going to provide a many-to-one solution where you could have maybe 10 machines migrating to a single target machine. As per this slide, I've got 2 machines going to one target machine. That's this thing called a Virtual Recovery Appliance, VRA. That VRA then provisions some replica virtual machines, which will look similar to these source machines, but they're basically just a set of VMX files and some empty VMDK files. Those replica machines stay offline, and so the replica disks that we've created, they're not doing anything, so we can temporarily mount them to this Virtual Recovery Appliance, and then we replicate in real time at byte level while everybody's still online on the production server from the C drive on source 1 to a mount point on the Virtual Recovery Appliance that then pushes data into the corresponding VMDK at the target side. Same for the E drive and the C drive from the other server. So if you've got 10 servers and you've got 30 disks, we're going to provision 10 servers, 30 disks. We're going to mount those 30 disks to the Virtual Recovery Appliance, and then we're going to synchronize the data into them. Then it's really easy for us to fail over once we've got the data in sync, because all we need to do is shut down the source machine, which will basically, you could do one machine, we could do multiple machines, but we'll shut down the source machine, we'll wait for any last changes to go across to the target machine, and then we can detach the VMDKs from the Virtual Recovery Appliance, inject a bit of bootable code into the VMDK, maybe some different network settings, the VMX Net3 driver for instance, and then we start the machine and it's online within 5 minutes. So that's what I'm hoping to show you today. So I'm going to switch over to my lab machines. And the first thing I'm going to show you is just very quickly, I have an ESX environment. It's only a small host, a single host. It's not got many machines running on it. But the machine we're going to use on here is this one here, W19 ESX7 VRA. That's a Windows Virtual Recovery Appliance. Really easy to provision. It's basically just a Windows server that you install the Carbonite Migrate agent onto. You don't even need to license it. So you can set one of those up as quickly as you can set up Windows. Takes 2 minutes to install the Carbonite software, and then it can be used as a VRA. I've got a separate video I'm going to do for Linux, but we have a separate Linux Virtual Recovery Appliance here, because when we're migrating Linux servers, we replicate Linux to Linux, or if we're doing Windows, it's Windows to Windows. So I'll probably show you a separate video to do that, but you can see that's what that other machine is there. But we're going to be focusing on this server here. So you can see it is online. It's not doing much at the moment. I've then got a Proxmox environment. Now this Proxmox environment is a KVM-based hypervisor, but the workflow that I'm going to show you here, it doesn't really matter that it's Proxmox. It could be another VMware environment, it could be VMware vCloud, it could be Azure or Amazon, it could be Proxmox, it could be a KVM environment, Zen, it could be a physical server. The source environment doesn't really matter. And I suppose I probably should have put these tabs around the other way so it makes a bit more sense. But yeah, this is my source environment. I'm going to the target ESX environment. So on this source environment, I have a Windows machine I've already provisioned just for this demo. But I mean, this could be running any application, SQL, Oracle, SharePoint, it doesn't really matter. And we're going to basically take a live copy of this machine while it continues to run and put it into this target ESX environment. So the other view I want to show you is I've got some RDP sessions to those machines because it's a bit easier to show things, and I can switch between them a bit quicker as well. So this is my Proxmox source machine. You can see its host name there, and then I've also got the VRA machine as well. So that's, again, it's a Windows. They're both Windows 2019. But in fact, this target machine could be Windows 2012 R2, 2016, 2019, or 2022. It doesn't really matter. And it will migrate servers with different versions of Windows as far back as sort of Windows 2012 R2. But we do have older versions of our agent that we could use with, say, Windows 2008. I think you'd probably struggle to get 2003 working with ESX with this workflow, but we do have other methods of doing that. But I'm sidetracking a bit here, and I want to focus on what I have, which is a Windows 19 machine. So the first thing I'm going to do is go to the Carbonite replication console. So you can see that on the screen now. In here I've got a few different machines in different environments. The server we're going to use today is this Windows 19 Proxmox source machine, and you can see my VRA machine just here. And then I've also got my ESX7 host that I've added into the console as well. Adding the servers is pretty easy. You just add a server name or IP address, a username and password, domain if you need it, and then they can just be added to the console. Adding the host, just for a quick note, is that you would go to Go, and then you would manage VMware servers, and you would add the host slightly differently, because we're not going to be replicating direct to the host. We just need to give it some credentials and make sure it's got certificates and things like that. So if we pick that source machine, I'm going to right click on it. I'm going to choose Migrate. I'll get given a choice of different wizards. So we have a file and folder one, a full server, and a full server to Hyper-V or ESX. So we're going to choose full server to ESX. You can see the volumes have been selected there. I choose the virtual recovery appliance. That's my Windows one that I want to go to. Then I choose my ESX host. I'm just using a standalone host, but if you're using vCenter, you're probably more likely to use your vCenter here instead. I'll get a few options pulled from these servers once it's got a bit more detail of them. Usually just takes it a few seconds. Here we go. So it's going to basically create a machine from Windows 19 Proxmox source to the IP address of my ESX host. So I've not got my DNS working correctly here, so I'm just going to just put that in there as ESX, just so it's a bit clearer when we look at the thing. But you can call this whatever. It's just the name of the job. I have a few different data stores here. I'm going to choose my SSD for this to make it a little quicker, and I can then specify the name of the new replica virtual machine that's been created. So that's the display name you'd see in vSphere. You can call it whatever you want. We call it the host name of the source and then underscore replica, but you can change that if you wish. You can change the number of processors, so you can see the source has 4 and 4 gig of RAM. I could say, well, I'll just create a machine with 2 processors and give it 8 gig of RAM. So you can change things up a little bit. In fact, I've probably got the it's 192, isn't it? So it doesn't really matter. But that's basically just going to say, create a machine with 2 processors, 8 gig of RAM. I can choose EFI instead of BIOS for the boot system. I can sometimes change the network adapter if we're working with older environments. You might still get the E1000 network in there, but this is all VMware, so I'm going to use that. I've also got the option to specify which virtual switch to attach each network adapter to. So if you've got multiple networks, you can choose each adapter and you can choose the appropriate switch. So I want it all on this VM network. Scrolling down, there's options for the drives, how big you want them to be created on the new machine, so how big are the VMDK is going to be. The source machine has a 60 gig disk, 20 gig used. I might say, well, I want a 120 gig disk in my new environment. And my F drive, I've just put that there so you can see multiple volumes. It's not really got any data on it. I could, again, increase this one to 10 gig, and then I can choose the data store and the type of disk I want to create. So I'm going to say make them both trim provisioned, put my C drive on the SSD, but leave the 10 gig one on a different volume, or you can put it on the same one if you wish. There are options to reuse VMDKs. I'll probably show a separate video on that because it gets a bit more confusing. But it means that if you have a copy of a VMDK, you can reuse it without having to send all the data over the network again. And all we're really doing here was resynchronizing the deltas, the differences between the two. For each network adapter, we'd be able to specify different network settings if you wanted, but I'm going to keep it all the same in today's demo. But this is where you can add different IPs and gateways and DNS. There is the option to do test failover, which basically clones the replica machine, spins it up on a private network or without any networking. And so you have the options for, what network to use. Maybe you spin it up on the isolated network, and you can specify where to create the clone disks that we're going to use. The cool thing about the test failover is that the users remain connected while you're doing the testing, but also the replication continues to the virtual recovery appliance because we're working with a cloned copy of that replica virtual machine instead. It does take a little while because you have to wait for the disks to be cloned. So it might take an hour or two to do a test, but it doesn't interrupt the production environment. There's some advanced options for what to do when we fail over, how we synchronize the data. You shouldn't have to change these things. The route through the network if you've got multiple network cards. And also the option to compress the data. Now this is a useful one because it reduces the amount of bandwidth. And as you can see, I normally set it to medium. That's normally sufficient. It doesn't have that much of an impact, but it will use some additional CPU cycles. So the normal agent, you wouldn't notice it running at all. But when we're doing the compression, it's going to spike, 5%, 10%, depends on the type of data. But it's very efficient, and it'll reduce the amount of data that gets sent over my network. There's also bandwidth throttling, where you can specify a fixed amount of bandwidth, or you can specify a rule so that on, say, weekdays between 6 in the morning, 6 at night, we've got a 10 meg link, and it basically restricts it. Outside of those hours, it would be unrestricted. And you can have multiple rules for different days of the week and things like that. Just means that if you've got voice over IP and terminal server and web browsing sharing the same network, you're not going to impact that because you can, well, at least during the working day. I'm just going to turn it off because I do want it to work as quickly as possible. Then we click next and we validate. So validation basically checks the settings I've given it, makes sure that they're all suitable, that there's enough space, that there's the right permissions, and so on. You can see this whole list here. Sometimes you'll get warnings, sometimes you get errors. You can fix them and then you can recheck and so on. But I'm just going to leave it as such, and I'm going to click finish. And you'll see a new job has been created. So this is the new job being created here. It's got a warning just telling me it's not in sync. You can also see I've already got a job running from an Ubuntu machine to the same ESX host as well, to that Linux virtual recovery appliance I showed you a second ago. So you can sort of manage lots of different jobs in the same console from different Windows and Linux environments. But you can see now it's provisioning, and it's currently initializing the virtual disk. So that means it's actually created a new replica virtual machine. We can see that if we go back to my ESX host. So if we have a look at my ESX host, and we just look at all the virtual machines on here, what you'll see is a W19 Proxmox source replica machine. So that's been created. You see those sort of settings are changing at the bottom as well. If we look at that machine, it's created a 120 gig disk because I resized it, and a 10 gig disk because I resized it. And you can see a bit more information about those disks, like their location and the name that they've used. So this is the C drive, and if I just expand this one out, you can see this is the F drive. And we've also can see that they're thin provisioned and so on. But this machine is going to stay offline. It's not going to get started up. And the reason for that is because these VMDKs that I was just showing you are actually going to be attached to my virtual recovery appliance. And if we look at the virtual recovery appliance, it's got a C drive of its own. That's the C drive for the virtual recovery appliance. And then it's got these two additional disks. And you can note that they're 120 gig. It's thin provisioned, and it's the C drive for that Proxmox replica machine that we're working with. So it's created both disks there, the C and the F drive as well. So if we go back to the console, see how it's getting on. It's now started synchronizing the data, sitting about 7%. It will take it probably about half an hour in my lab just to synchronize it. It's not the quickest network and not the quickest hardware, but it started synchronizing data. We can see it's still got another 20 gig to go. And we can also see that there is 2.3, 2.5 gig sent, and it's only sent 1.3 over the network because of the compression. So the compression is pretty effective. Depends on the type of data. It'll work better on big things like SQL databases with lots of white space than it will on a file server with lots of JPEGs, because we're intelligent enough to see the JPEG extension and we don't try and compress them. But not that you'd see any return from additional compression on it either. So this is now in place. It is synchronizing. We can see some of that synchronization going on. If we have a look at my source machine, you can see it's still a live server. I'll maybe just create a flat file on the desktop, and we'll call this Proxmox, so that's what that source server is. Just bring it to the side here. So it's a live running server. If I now look at my ESX host, I can show you those mount points. So we'll go into the file system here, and we'll have a look on the C drive, and in program files, Carbonite, replication, and service. So it's hidden away a little bit here. There is a directory called mount directory. We go in there, and we can see the mount points. So you can see there's a C drive and the F drive, and we've got the name of the machine, the source machine's name, and some GUID stuff just to identify it, so that we don't end up, you might have two servers with the same name on your network, but we can differentiate between them here. If you had other servers, you'd have more names and you'd have more drive letters and so on. What's cool is I can go into that C drive, I can go into the users directory, and I can go into administrator, and I can see the live replication or the mirroring going on. So you can see that's that Proxmox file. And at the moment, we're still synchronizing. So in fact, we haven't sent every file over yet. We're still probably at 21%. So we've only done a fifth of the file system so far. But we do prioritize new change. So when I created that Proxmox file, that was a new change on the production server. Our filter driver that captures real-time byte level changes to the file system saw that change happening, saw that file being created, and immediately sent that instruction to do the same thing on the target. So we can have a look at the source machine, and if I was to just maybe change this to, we'll change it to VMware this time. By the time I switch back to my target, there might be a little bit of latency because it is doing this stuff. This will update in a second because I've committed a change. There we go. So once the mirror's out of the way, the synchronization that's happening in the background, these changes happen instantly. But because there's other stuff in the queue, because we're synchronizing data, and we have to make sure things get written in exactly the right order on the target, there was a slight bit of latency there, but it's fractions of a second. But if you're synchronizing a big database, we're going to be capturing all the byte level changes in parallel to synchronizing it, and it will all get put into the right shape to end up with a complete file that will be virtually identical on the target, ready for us to cut over. And then when we're doing the cutover, we're going to shut down the source machine, and any final changes will be synced across so we don't lose anything, and you'll have an identical copy to whatever it was on the source when you press the failover button. So let's do a failover. Well, in fact, I'm going to have to wait a little while for the mirror to complete first. Jumping ahead of myself here. So it's at 35%. I'm probably just going to pause the video now for probably another 10-15 minutes, and I'll come back to it and we'll have a look at the failover. Okay, so it's at 99.9%, and any second now it'll go to protected. So the data is now in sync between the source and the target. So everything has been synchronized over as much as we can. It'll only be whatever's running in the memory on the source machine that's still on the source, and when we do the cutover in a second, that'll get flushed to disk, sent over to the target, so there'll be zero data loss. Before I do that, let's just double check the machines are still all okay. So you can see this is my ESX VRA machine, and here's my source machine. Again, we'll just say we'll just change it to something like about to failover. So we should hopefully see that change onto the target machine. As I said before, it happens pretty instantly once the data is in sync because we're just replicating the real-time change. I could leave it now for a few days until I've got a few servers ready to cut over at the same time, but I'm going to trigger the failover now. So we'll notice this will shut down because it will get disconnected as a mount point, and the first thing that we'll really see is this source machine being shut down. So we're going to trigger the failover, make things a bit clearer. I'll just bring this in front of my replica machine. We'll choose the job and make sure I'm picking the right one, and we're going to do a failover. I apologise for my dog in the background. I'm sure she'll settle in a second. So we're going to cut over to live data. And you maybe saw there was the test failover there as well. But as I said, that will take it a little bit longer because it has to wait to clone the actual disks. So it'll depend on the speed of your VMware infrastructure. as to how long that will take. But the first thing we'll see is really this source machine will get shut down. So we do that in a managed way. Sometimes it takes us a few minutes, just because Windows will take a few minutes to shut down cleanly. The idea being, if you've got something like SQL running on your source machine, all those databases will be closed and shut down, and the data will get flushed to disk and synchronized over to the target so that we don't lose anything. Okay, so that was the machine just shutting down. Took it a couple of minutes, bit out of our hands. It takes Windows, as long as Windows takes a shutdown, but we need it to happen so that we don't lose anything. So it's quite an important wait. You can see we've now switched over to the VRA machine in the background there, because the session was closed to the source machine, and we can see that it's now failing over. In fact, it's failed over because in a lot of ways it has completed that process now. So you can see that mount point's been disconnected, so the file closed there as well. So we can have a look now on my VMware environment to see how it's getting on. So let's switch over to that. So the source machine, you can see the Proxmox source is now offline, it's not running. The ESX host, that replica machine has now been started. You can see those processes were happening here to start the server up. I can then connect to that machine, and we should see it started up. Because I failed over the IP address, I should be able to connect to the machine using the same IP. So let's try that. It's a bit quicker than me trying to log in through the Windows console. So we're going to pick for the Proxmox source. Now, I'm saying that's the Proxmox source machine. And you can see it's logging in, and it's still known as W19 Proxmox source because that's my connection. And you can see though, there's that file that I made the changes to, and we can see the host name is there. But just to be clear, because it's a bit confusing when you're working with different virtual machines everywhere, if we have a look in my VMware environment, this is the replica machine, so this is the machine, but I will actually try and quickly join this machine because it makes a bit more sense, I think, if I show you that. And we'll just send some keys to it. Oops, such a fiddly. Get this all the time in VMware. I'm not quite sure why. Sometimes it puts the keys off the side of the screen. There we go. So I guess I'm going to send it some keys, which I'm doing here. Guest OS, send keys. There we go. Sorry about the fiddling about that. Right, so if I log into this machine, we'll get the same. Log into the machine. We'll get the same desktop as we saw a second ago. So it's got the host name, W19 Proxmox source, and it's got the file that we made the changes to that are about to fail over. It warns us that the machine didn't shut down cleanly. That's just because we don't see the last file system being modified as the server shuts down, so we can ignore that. But as you can see, it's got the host name failed over, even though we are now running on that replica machine on my VMware environment. So yeah, hopefully that made some sense. If you've got any questions, you can always send me a message, either on YouTube, or you can email aabs@opentext.com. Thank you very much for watching. Thank you very much. Bye bye.